On this occasion, we will be taking a look at the base and the height of a triangle as it pertains to the intention of finding the area of the triangle by making use of the formula half base times height. Sometimes students are not really quite clear on what to call the base or the height of the triangle when making use of such a formula. We will clarify the identity of the base and height of the triangle in order that students might be able to find the area of the triangle more efficiently. When finding the area of a triangle by making use of the formula half base times height, the height goes from the base to the vertex that is opposite to the base. So we will identify one side of the triangle as the base. That is our first duty. The height goes from the base to the vertex that is opposite to the base. There you have the base, the vertex that is opposite to the base. As a matter of fact, the triangle has 3 vertices. When you draw the line representing the base will touch 2 of the vertices. The next vertex that we are talking about, which is the one opposite to the base, is the only other one that is left. That is easy to identify. The one opposite to the base. From the base to the vertex opposite to the base. Not only that, there's your height. The height must be perpendicular to the base. In the end, the most important thing is that the height is perpendicular to the base. If that is not true, then we will never be able to find the area of the triangle. The height has to be perpendicular to the base. And there we have another triangle, which is a right-angled triangle on this occasion. This triangle is right-angled. Therefore, we already have sides that are perpendicular to each other. A right-angled triangle has 2 sides that are perpendicular to each other. One may be used as the base and the other as the height. Because they are already perpendicular, one may be used as the base and the other may be used as the height. We choose that side to be the base, then the other side that is perpendicular to that one has to be the height. As usual, the height is required to go from the base to the vertex that is opposite to the base. On this occasion, the height is at one extreme of the base. The height will be all the way out here, which is of course the next perpendicular side of the right angled triangle. So we go from the base to the next vertex. That is what the height is supposed to do. But it is not just supposed to go anywhere. It has to be placed in such a way that the base and the height are perpendicular. The height will therefore have to be placed there at one extreme of the base, which turns out to be the other of the 2 perpendicular sides of the right angled triangle. The height goes from the base to the vertex that is opposite to the base. We need to identify the base first of all. Whatever we have as the height of the triangle, it is required to go from the base to the vertex that is opposite to the base. And then what do we know after that? Well, it needs to go to that vertex. There's only one other vertex apart from the 2 vertices joining the base. So there's only one other. Not only that, the height must be perpendicular to the base. This requires that the base be extended. There's no way that we can draw a line that is perpendicular to the base, which passes through this vertex and will also pass through the base. if we draw a line passing through this vertex, for it to be perpendicular to the base, it will not pass through the base. Therefore, we need to extend the base in this manner that when we draw the line segment which is perpendicular to it, it will also pass through this vertex. So there's your height. And as usual, the height is expected to be perpendicular to the base. The height must be perpendicular to the base. This requires that the base be extended as we have it right there. And there we have a demonstration of the height being perpendicular to the base. On this occasion, it does not pass through the base. There we see that the line segment that represents the height does not have to pass through the base or even touch it, but it must be perpendicular to it. The height must be perpendicular to the base even if it does not pass through the base. And we might have that on some occasion. And in the event that this occurs, then this is our design. This is the approach that we have to take in order to get the base and the height to be perpendicular, which is the requirement of finding the area of any triangle. We do not need to use a horizontal side of any triangle to represent the base. If we are identifying the base of any triangle, we do not have to use a horizontal side. It can be any side that we identify as the base. When we identify the base, the same thing holds. Any side that we choose as the base, the height must go from that side to the vertex that is opposite to it. The height has to go from the base to the vertex that is opposite to the base. Any side that we choose as the base. Not only that, finally, the height and the base has to be perpendicular to each other. The height must be perpendicular to the base. There we have it. We do not need to have a horizontal side of a triangle in order to use the formula half base times height. We just need to identify one side of the triangle as the base. The height will go from the base to the vertex that is opposite to the base and also has to be perpendicular to the base. We will finish up by showing how we might have the base of a triangle and the height. As we see in this first case, the base is just chosen randomly, any one of the three sides, but the height cannot be chosen randomly after that. It has to go from the base to the vertex opposite to the base and must also be perpendicular to the base. Notice on this occasion, the height is close to one end of the base, but it does not matter. As long as it goes from the base to the vertex that is opposite to the base and is perpendicular to the base, then that is accurate, and that might be used to find the area of your triangle. And there's your favorite. As you see, we have chosen one side to be the base. When we intend to draw the height perpendicular to the base, that is, that height has to go from the base to the vertex that is opposite to the base, which is this one. So the height has to go to this vertex. If we need to get that height perpendicular to the base, then it will not pass through the base. Therefore, we will have to extend the base as we have seen before. This is not a new occurrence in this audiovisual. Therefore, you should have some understanding of this before now. Now, the final one, your favorite, the right-angled triangle. No difficulty with the right angled triangle. We already have two sides that are perpendicular to each other. We may therefore say one is the base and one is the height. The right angled triangle is our easiest candidate for finding the area of a triangle. The base and the height must be perpendicular to each other, and we already have two sides that are perpendicular to each other. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.